This presentation is designed for Java developers, API architects, and security specialists. We'll dive into the intricacies of API security with a focus on rate limiting and throttling best practices. This course aims to equip you with the knowledge and tools necessary to implement these practices effectively, ensuring robust and secure API environments.
This course provides a comprehensive overview of rate limiting and throttling best practices specifically for Java developers, API architects, and security specialists. Throughout this course, we will delve into several key topics. Firstly, we'll start by understanding the fundamental concepts of rate limiting and throttling. This will lay the groundwork for why these practices are crucial in API security. Next, we will explore best practices for their implementation. This section will offer practical advice and strategies to ensure effective and secure rate limiting and throttling within your APIs. Following that, we will examine the common algorithms and tools used for rate limiting and throttling. Understanding these will help you in choosing the right approach and technologies for your specific needs. Lastly, we'll present real-world scenarios and use cases to ground your knowledge in practical, real-life applications. By the end of this course, you should have a well-rounded understanding of how to apply rate limiting and throttling effectively to enhance your API's security and reliability.
In this slide, we delve into the importance of rate limiting and throttling. The purpose behind implementing these mechanisms is multifaceted. Firstly, they serve to prevent API abuse and protect against denial of service (DOS) attacks. By controlling the rate at which requests are processed, you can ensure that no single client can overwhelm your system. Secondly, rate limiting and throttling help to ensure fair usage and resource allocation among all users. This way, every user gets a fair share of the system's resources, maintaining equity and preventing any single user from monopolizing the service. Finally, these mechanisms are crucial for maintaining performance under high load conditions. By efficiently managing incoming requests, your system can sustain its performance levels even when demand spikes unexpectedly. As a quote aptly puts it, "In the world of API security, rate limiting and throttling are not just features, they are necessities." These practices are essential for the robustness and reliability of your API services.
So, let's dive deeper into the concept of rate limiting, starting with its definition. Rate limiting is essentially a strategy used to control the number of requests a client can make within a specified time period. This is crucial to ensure that no single client can overwhelm the server with excessive requests, thereby maintaining fair usage and optimal resource allocation. Common techniques for implementing rate limiting include the token bucket algorithm and the fixed window algorithm. The token bucket algorithm allows a certain number of tokens to be added to a bucket over time, and each request consumes a token. When the bucket is empty, further requests are denied until more tokens are added. On the other hand, the fixed window algorithm divides time into fixed intervals and limits the number of requests a client can make within each interval. Understanding and implementing these techniques helps in safeguarding your API against abuse while maintaining its performance even under high load conditions.
API throttling is a mechanism that temporarily blocks clients when they exceed a predefined request rate. Unlike rate limiting, which controls the number of requests within a specific time frame, API throttling takes a more aggressive approach. It focuses on controlling the rate at which requests are handled and processed, effectively placing a temporary block on clients that send too many requests too quickly. This is particularly effective in scenarios where preventing server overload is crucial, providing a stricter form of request regulation to ensure system stability and performance.
On this slide, we delve into the token bucket algorithm, a key method for managing API throttling. The basic principle of the token bucket algorithm is that each request consumes tokens from a bucket. Tokens are replenished in the bucket at a predetermined fixed rate to ensure that the system can handle bursts of requests up to a certain limit while maintaining a controlled processing rate over time. Let's take a closer look at how this works with a practical example implemented in Java. The provided code showcases how to create a token bucket class. First, we define the capacity of the bucket, which is the maximum number of tokens it can hold, and the refill rate, which determines how quickly tokens are added back to the bucket. Java public class token bucket, private final long capacity, private final atomic long tokens, private final long refill rate, public token bucket long capacity long refill rate. This dot capacity equals capacity. This dot tokens equals new atomic long capacities. Dot refill rate equals refill rate. Next, we use a scheduled executor service to periodically refill the bucket with tokens. Java, refill tokens periodically. Scheduled executor service scheduler, executors.new scheduled thread pool 1. Scheduler schedule at fixed rate, this refill token 01, time unit dot seconds. The refill tokens method ensures that the bucket is refilled up to its capacity at the specified rate. Java private void refill tokens, long current tokens equals tokens.get. Long new tokens equals math min capacity, current tokens, refill rate, tokens.set new tokens. When a request comes in, the try consume method checks if there are enough tokens available. If tokens are available, it decrements the token count and allows the request. Java public boolean try consume, long current tokens equals tokens.get. If current tokens 0, tokens.decrement and get, return true, return false. This algorithm excels in environments like AWS API Gateway, where bursts of requests are common but need to be controlled to prevent overloading the system. The token bucket algorithm ensures capacity to handle bursts while maintaining a steady flow of requests through consistent refill rates.
Continuing our course, let's explore the leaky bucket algorithm. Here's how it operates. Requests enter a bucket at various rates. These requests are processed at a fixed leak rate. Essentially, the leaky bucket algorithm smooths out bursts of requests by processing them at a consistent rate, thus avoiding spikes. To bring this concept into action, let's look at a Java implementation. Below is a simple implementation of the leaky bucket using Java's concurrency utilities. Java import java.util.concurrentatomic.atomic.long, public class leaky bucket, private final long capacity, private final atomic long tokens, private final long leak rate, public leaky bucket, long capacity, long leak rate, this dot capacity, this dot tokens, new atomic long 0, this dot leak rate equals leaking tokens periodically, scheduled executor service scheduler equals executors.new scheduled thread pool 1, scheduler.schedule at fixed rate, this leak tokens 0, 1, time unit dot seconds. Private void leak tokens, long current tokens equals tokens.get, long leak tokens equals math min current tokens, leak rate, tokens.add and get dash leak tokens. Public boolean try consume, long current tokens equals tokens.get, if current tokens capacity, tokens.increment and get, return true, return false. In this example, the leaky bucket class initializes with a specified capacity and leak rate. A scheduled task periodically removes tokens from the bucket at the defined leak rate. The try consume method checks if there's space in the bucket to add another request, and if so, increments the token count and allows the request to proceed. This algorithm ensures that requests are processed at a steady rate, thereby preventing overloads. This is particularly useful in scenarios where you need to apply throttling and rate limiting policies, ensuring a more balanced and sustained request processing rate. Continuing our discussion on rate limiting, let's now look at defining API usage plans and implementing throttling and rate limiting policies in Java. We'll be using Spring Boot and the Bucket4j library for our implementation. First, you need to include the Bucket4j dependency in your project. Here is the Maven dependency. XML, dependency, group ID com.bucket4j, artifact ID bucket4j-core artifact ID, version 8.1 version, dependency. Next, let's see an example implementation. This example demonstrates a basic rate-limited API endpoint using Spring Boot. Java at rest controller public class rate-limited controller, private final bucket, public rate-limited controller, bandwidth limit equals bandwidth.classic20, refill.greedy duration.of hours 1, this.bucket equal bucket.builder, add limit, build. At get mapping, API/resource, public response entity string get resource, if bucket try consume 1, return response entity.ok, request successful. Else, return response entity.status, HTTP status.too-many requests, body, rate limit exceeded. Here, we define a rate-limited controller with a single API endpoint/API's resource. We configure the rate limiter to allow 20 requests per hour using the bandwidth.classic method and greedy refill strategy implemented by the Bucket4j library. When a request hits the endpoint, the try-consume method checks if the request can be processed based on the rate limit. If the bucket has available tokens, the request is processed successfully. If not, it returns a 429 too many requests response. This approach helps us manage traffic to our API effectively, ensuring that our resources are not overwhelmed by excessive requests.
To ensure the effectiveness and reliability of our rate limiting implementation, rigorous testing and monitoring practices are crucial. Let's first discuss load testing. Tools like Apache JMeter and Gatling allow us to simulate high load scenarios, helping us understand how the system will behave under stress. Load testing is essential to verify that our rate limiting policies are correctly enforced and to identify any potential weaknesses or bottlenecks. Next, we need robust monitoring in place. By integrating logging and monitoring tools, such as Prometheus and Grafana, we can gain valuable insights into rate-limiting activities. These tools will help visualize usage patterns, detect anomalies, and provide real-time alerts. Effective monitoring ensures that our rate-limiting strategies are functioning as intended and allows us to make informed decisions to optimize system performance and security. Let's discuss some real-world use cases where rate limiting can effectively manage API usage and ensure system stability. First, consider a social media API. A common issue is preventing bots from spamming posts. To tackle this, you can apply rate limiting on post creation endpoints. This will control the number of new posts that can be created within a specific time frame, thereby mitigating the risk of spam and preserving the integrity of your platform. Another example is in e-commerce platforms. A significant problem faced here is bots attempting to hoard inventory, which can result in unfair advantages to some users and a poor experience for genuine customers. Implementing rate limiting on purchase API endpoints can help address this issue by controlling the number of purchase requests that can be processed in a given period. By applying these strategies, you can manage traffic efficiently, protect your system from abuse, and enhance user satisfaction.
In conclusion, rate limiting and throttling are indispensable techniques for managing API usage and ensuring the stability of your systems. Proper implementation involves selecting the appropriate algorithm, configuring precise usage policies, and continuously monitoring performance to adapt to changing needs. By applying these strategies within a Java environment using Spring Boot, you can create robust, scalable, and secure APIs that stand up to abuse and maintain integrity. For those of you looking to dive deeper into the topic of rate limiting and throttling, I've compiled a list of resources that can be incredibly helpful. Under Articles and Guides, you'll find Best Practices for API Rate Limiting by Stoplight, which provides a comprehensive overview of best practices for implementing rate limiting. Another valuable resource is Rate Limiting a Spring API using Bucket4j by Baeldung, which offers a practical guide specifically tailored for Java Spring Boot users. As for tools, there are several that can facilitate the implementation of rate limiting. AWS API Gateway offers a robust suite of features for managing API requests at scale. Bucket4j is another excellent tool, particularly for those using Spring Boot, known for its efficiency and flexibility. Lastly, Apache JMeter can be useful for load testing and ensuring your rate-limiting policies are effective under stress. These resources should equip you with the knowledge and tools necessary to implement robust rate-limiting and throttling strategies, making your APIs more secure and scalable. Thank you for taking the time to go through this course. We hope you found the content insightful and valuable. If you did, please leave a like and share your thoughts in the comments below. Your feedback is greatly appreciated and helps us improve. Also, don't forget to share this course with your friends and colleagues who might benefit from it. Your support is what keeps us going. Implementation code examples and further reading materials are available through our course repository. This resource will help you understand the practical application of the concepts we've discussed. You can find detailed code samples that you can experiment with and modify to suit your own projects. Additionally, the further reading materials will provide deeper insights and more comprehensive understanding. Don't forget to utilize these resources to solidify your learning experience.